Good afternoon. I'm teacher Pearson from Andalucia Academy. As we walk our students to success, we do everything possible in our power to make sure that they excel to achieve their goals. And this is such a program where we teach online so that they can access any information they need to improve their grades at any time. So today I'm going to teach about the mole concept. This topic is very fundamental in chemistry because everything involving calculations, amounts of substances reacting, depends on the mole concept. And in most cases, students have some sort of difficulties, and we are trying to ease that by trying to explain to them and make things as simple as possible. Now, before I introduce the concept, I'd like you to take a scenario where you are sent to the market. You know, when you go to the market, you'll buy different items. You can buy, let's say, oranges, lemons, cabbages, and you can also buy packets. Let's say packets of salt. You can also buy bags of different quantities. Now, when you go to the market, you buy what you want, and you normally put them on a scale. If you go to that scale, there is a standard 1 kg stone, and that is international because it's actually kept in Paris. All calibrations about masses are based on that one stone. Now, I've told you here that you can buy any amount you want, but in chemistry, that's not what happens. When we want to buy, let's say in chemistry, you must buy a fixed number of every item. I'll give you an example, like if you go to the market, you must buy 10 oranges, 10 lemons, 10 cabbages, 10 packets of salt. Everything must have the same number. Now, these have to be put on a standardized scale. Now, I'll explain to you how that scale is carried about. But first of all, in chemistry, what is this specific number that we use? It is called Avogadro's number. The students don't need to memorize this because normally it's given in the exam paper worksheet. So, but it is 6.023 times 10 to the power 23. In the examination for ease calculations, normally they remove the 0.23. They just write 6.0 times 10 to the power 23. Now, when we look at chemistry, this gives you the number of particles. So what are particles? Particles are the units or building blocks of matter in chemistry. So these particles could be electrons, they could be protons, they could be atoms, they could be molecules, or units of compounds. For example, we can have electrons, we can have protons, we can have a molecule like, for example, hydrogen. We could also have a molecule like ammonia, or we could have a unit of compound like sodium carbonate. Now, when I have this exact number of each unit, we must put it on a scale. How do they get that scale? They used an isotope of carbon-12. This scale was made using the carbon-12 isotope. Isotopes are atoms of the same element, different atomic number, that means same number of protons, but different neutron number. Or you can say they have the same atomic atomic mass, but different mass number. So on this scale, if I took this number of atoms, if you took this number of atoms of carbon, it will give me 1 mole. And this 1 mole will actually weigh 12 grams. So if I took this number of atoms of carbon 12 and I put on this scale, it will weigh 12 grams. Now I will use this scale to get different masses of different elements, different substances put on the same scale, which means relative, because in comparison to. So for example, if I had sodium, the same number of atoms of sodium, and I put on this scale, they will weigh 23 grams. If I took hydrogen, 1 mole of atoms of hydrogen, it must be the same number. They will weigh 1 gram. Now, these masses are given for you in the periodic table. But there is a catch which we have to do here. When I have the mass of 1 mole of atoms of sodium relative to that of carbon, we call it relative atomic mass, because we are weighing the mass of 1 mole of sodium atoms in relation to 1 mole of carbon atoms. Now, therefore, what does a mole mean? It actually means a different way of measuring the amount of substance, right? Especially in our chemistry. Instead of using our kilograms, instead of using grams, we could actually measure the amount of matter in terms of moles. So a mole is another way of trying to ascertain the amount of substance which we'll need for our maybe chemical reactions, because it is very important that we know the amount of substance which will react and also the amount of substance which we shall produce. Now, to be specific, if I take something like from now on hydrogen, carbon, sulfur, when I write symbols like that, I'm not referring to one atom. I'm actually referring to 1 mole of atoms, which means I'm taking this number of atoms of hydrogen, this number of atoms of carbon, this number of atoms of sulfur. Now, these particles we said could be atoms, but they could also be molecules. So when I write NH3, I mean 1 mole of molecules of ammonia. But you can see that ammonia is not a unit alone. It has other elements. So which means that when I take the mass of 1 mole of ammonia, I must look at what are the elements which make ammonia. You can see here I have 1 mole of nitrogen, and 3 moles of hydrogen. So to get the relative now is because it's a molecule we call relative molecular mass. So it is the mass of 1 mole of a molecule on a carbon-12 scale. Remember I told you on a carbon-12 scale, 1 mole of carbon atoms will weigh 12 grams. So how do we get there? We call it now MR. If it is atoms, we call it AR. AR means relative atomic mass. MR means relative molecular mass. If we are dealing with molecules, that means covalently bonded. So they will give you in your periodic table, nitrogen is 14, hydrogen is 1. So to get the relative molecular mass of ammonia, I need to add 14, which is 1 of nitrogen, plus 1 times 3 for hydrogen, which gives me 14 plus 3, which is 17. So I could use the same thing to get, for example, for sulfuric acid, which is H2SO4. Here I have 2 hydrogen. They'll give you hydrogen is 1, sulfur is 32, and oxygen is 16. So what I'm going to do here is I will multiply 1 by 2 because there are 2 hydrogen. 1 times 2. One times 2 plus, now I have sulfur is 1 and there are 32, so 1 times 32 plus, I have 4 oxygen, 16 times 4. When you multiply, this becomes 2 plus 32 plus 64, which will give you 98. So which means if I take this number of units of sulfuric acid and I put on that scale, it will weigh 98 grams. So that is our relative molecular mass. But suppose we have ionic compound. Let's say, for example, sodium carbonate. Now, sodium carbonate is an ionic compound. So instead of saying relative molecular mass, we use relative formula mass. Relative formula mass. It means the mass of 1 mole of an ionic compound represented by its formula. So we do the same way here. Sodium is 23. Carbon is 12. And oxygen is 16. So I have to find out how many atoms of sodium are there, or moles of, that will be 2 moles. So it will be 23 times 2 plus carbon is 1, 12 times 1 plus oxygen are 3, 16 times 3, which will give me a total of 106 grams. So this is how we measure the amount of substance in chemistry. Instead of using grams or kilograms or packets, we could use moles. But what I've done here is I've only written the masses of 1 mole of the substance. Now, how do we find the number of moles? We can find the number of moles in 2 ways. Remember, the first thing I told you is the number of particles. The number of particles must be Avogadro's number, which is 6 times 10 to the power 23 for easy calculation. So you are given, for example, I have 3 times 10 to the power 18 atoms of sodium. How many moles are there? It's quite simple. You say, if I had 1 mole of atoms of sodium, there will be 6 times 10 to the power 23 atoms. But now I have this one. It could be more, it could be less. So I have now 3 times 10 to the power 18 atoms. How many moles are those? This is 1 mole. So I have X moles. You cross multiply. But it's better to write a simple formula. What I've done here is moles. 1 mole is this. X moles is that. So what we need is to get the number of moles. I'll just divide the number of particles given, particles, over Avogadro's number, which is 6.0 times 10 to the power 23. This is quite simple. Once you know the number of particles and you know your Avogadro's number, which is always given for you, you just divide that number of particles by Avogadro's number and you get the number of moles. Now, there are cases where they will put for you a small trick. Let's look at an example. I have ammonia. Now, If they ask you for the number of moles of atoms present, let's say I have 1.2 times 10 to the power 24 molecules of ammonia. Molecules of ammonia. Now, they are asking you to find the number of moles of atoms. Atoms. You must know that in 1 mole of ammonia, I have 4 atoms, or 4 moles of atoms, because 1 mole of nitrogen and 3 moles of hydrogen. So you have to be very careful. Read the question clearly. These are number of moles of molecules. Now we need atoms. So what we do is, I have 4 moles of atoms. Is that okay? So what I need to do here is, I can first of all get the number of moles of ammonia, multiply by that, and multiply by 4. But the quickest thing to do is, since I know there are 4 moles of atoms, I multiply this one by 4. So my 1.2 times 10 to the power 24 times 4 will give me the total number of moles of atoms present. So what I do here will be 4.8 times 10 to the power 24. Now, when I divide that number by Avogadro's number, I can actually get the number of moles of atoms. So students have to be careful. When you read the question, you must analyze the key words which they require. So I can now divide this one by 6 times 10 to the power 23. Now, from your laws of indices, when you are dividing, you subtract the powers. So I could write this one as 4.8 times 10, because 24 minus 23 is 1. We don't have to write the 1, so divide by 6, which is the same as 48 over 6, which gives me 8 moles of atoms present in this number of molecules of ammonia. So you must be very careful about that. So I hope this one is very clear. We could go to the next part. I've told you that if I take something like sodium hydroxide, right? This represents 1 mole of sodium hydroxide. So, but in terms of relative formula mass, what will be the mass in grams? What I do here is, I know sodium is 23, plus oxygen is 16, plus hydrogen is 1. This gives me 40. Which means if I took 1 mole of sodium hydroxide and I put it on that scale, it will weigh 40 grams. Now, suppose I do not have the 40 grams, but I have, let's say, 16 grams. I have 16 grams of sodium hydroxide. How many moles are those? Still, it is very simple. You know, I have 40 grams of sodium hydroxide is 1 mole. What about 16 grams of sodium hydroxide? That will be X moles. Cross multiply. So you get another simple formula for getting the number of moles. So what have I here? I've been given the mass of sodium in grams. So I will have number of moles is equals to mass over, I'm going to give you everything, AR. Suppose I'm dealing with atoms or elements. AR refers to relative atomic mass. Now, in this particular case, I am dealing with a compound, an ionic compound. So I should have another one, which is mass over MR. MR is for molecules. So for example, if I want the number of moles of ammonia, the number of moles of carbon dioxide, I use mass over MR, where MR is the relative molecular mass. But now, since I'm using ionic compound, the relative formula mass is still represented by Mr, but you must know it is mass over RFM. But the RFM in your exam will still be written as what? Mr. So in this case, what we have here is, I will just put 16, which is the mass given, over the relative formula mass of sodium hydroxide, which is what? 40. So by 4, 4, by 4, 10, which I'll get 0.4 moles. So what I need here to do is that I must know, is my question such that my number of, or the amount of particles, I mean the amount of substance is given in the number of particles or in masses. So that will help me to choose the right formula. Am I dealing with atoms of elements? I use AR, relative atomic mass. Units of molecules, I use MR, which is relative molecular mass. I showed you how to calculate the relative molecular mass. And if I'm dealing with ionic compounds, it is still, in your exam will be MR, but it actually means relative formula mass. I divide the mass by the relative formula mass, and I get my number of moles. Basically, for part 1 of today, we are going to use only the 2 formulae, because moles is divided into 3 parts. We are going to deal with when you dissolve something in water, or when you are dealing with volumes of gases later on. So today, I will only apply the 2 formulae so that you are able to get used to what sort of questions come when masses are given, or what sort of questions come when the amount of substance is given in the form of particles. So let's have some examples. Here we are going to look at application of number of moles using formula 1, where you have number of moles is equals to number of particles over Avogadro's number. So here, I'll just give 2 examples because this one is very easy, and in most cases, it's a 1 or 2 mark question. Let's say, for example, I have 3 times 10 to the power 36 atoms of calcium. How many moles are there? It's quite simple. What you do is number of particles over Avogadro's number, which means the number of moles will be given by 3 times 10 to the power 36 over 6 times 10 to the power 23. And you can use your calculator quickly. This one becomes 3 over 6 times, if I subtract 23 from 36, I'll get 13. 10 to the power 13. But now, when I divide 3 by 6, I get 0.5 times 10 to the power 13. But this one will not be in standard form. So I must remove this because the number must be between 1 and 9. So this will be 5 times 10 to the power. Now I reduce this one by 1, it becomes 12. That is quite simple when we come to having getting the number of moles when the number of particles are given. What I need you to remember is where they give you a compound which contains more than 1 element, then you have to be careful how many atoms of each element are present. Now, this formula is easy, so I'm going to go to the second formula where we need to use number of moles is equals to mass over, let me use generally RFM. Where do I use this? How do the questions come? The first one is to find the number of moles in a given mass of a substance. Let's say I have 12 grams of calcium carbonate. How many moles are there? You see, I've been given my mass in terms of grams. So the first thing I have to do is, if I took 1 mole of calcium carbonate, how much will it weigh? how many grams will there be? So they will give me the periodic table, or they will give me the relative atomic masses of calcium, carbon, and oxygen. So your calcium is 40, carbon is 12, and oxygen is 16. So if I have 40 plus 12, now 3 times 16 is 48. I add all this, I'll get 100, which means that if I took 1 mole of calcium carbonate, it will weigh 100 grams. But I've been given only 12 grams. How many moles are there? So it will be the formula, which is mass, which is 12 over RFM, which is 100, which will give me 0.12 moles. So this is the easy part, but you need to know it because when it comes to chemical reactions, you'll be able to calculate number of moles of every substance which is going to react when their masses are given. So you must remember this. Now, the next thing we have to do here is, suppose they want me to find the percentage composition of an element. Let me give you magnesium sulfate. Now, they want me to find out by percentage how much is magnesium in magnesium sulfate, how much is sulfur in magnesium sulfate. So the first thing is I have to get the RFM, where magnesium is 24, sulfur is 32, and oxygen is 16 times 4 is 64. So what do I get here? This is 0. And what do I have here? 9 plus 2, 11 plus 1. Is that okay? 120. 24 plus 32 plus 64. This one will be 120. Which means that if I took 1 mole of magnesium sulfate, they will weigh 120 grams. But what percentage of magnesium is present? So what is my mass of magnesium? 24. So I write percentage of magnesium will be mass of magnesium, which is 24 over 120 times 100. Then mass of sulfur, to get in percentage form, will be sulfur is going to be equals to 32 over 120 times 100. And that one of oxygen, percentage of oxygen, will be 64 over 120 times 100. Then you can go to your calculator and quickly get the percentages. So one way of using masses is to get the percentage composition, which means you have to remember that sometimes the masses are given in percentages, not in grams. So once they give you in percentage, take as if it's grams. For example, it's like you took 100 grams of a substance. Out of this, let's say, for example, if we calculate this one, now you should be able to calculate the percentages. Now, why do I start with the percentages? Because there is what we call number 2, calculating the empirical formula. What do we mean by empirical formula? This is the smallest whole number ratio in which the elements, the atoms combine in the compound. So, in most cases, they will give you the amount of each element as a percentage. The amount of each element as a percentage. Let me have one here. I have a compound which contains potassium, and the percentage of potassium is, this time they gave it in masses. Let's first start with masses. The mass of potassium is 56. Potassium is 56.5. And the mass of carbon is 8.70. And oxygen is 30. 4.5. Remember, these percentages must add up to 100 because we're taking, okay, these are different masses. But what are we going to do? First of all, we have to, step 1, change these masses into moles. Change these masses into moles. How do you do it? The formula, mass over relative formula mass, which means for potassium, we are going to use AR, which is 56.5 over, potassium's relative atomic mass is 39. Because we want to get all number ratios, then for carbon will be 8.70 over 12. And then for oxygen will be 34, actually it's supposed to be 34.8. 34.8 over 16. Now, when you calculate this, you'll get 1.4487.